Okay, so this is going over how to run a two-sample means test when the samples are independent, okay? And so this is going to use my egg data. And so the example is that, the first example is that in my egg data, I collected whether or not the data were brown or white. And so these are independent samples because there's no connection between brown eggs are one population, white eggs are another. And so this is the hypothesis that I'm testing. And let's go ahead into SPSS and look at how to run this. Okay. So here's my egg data that at this point you know and love, as do I. And I am going to run a test of comparing whether or not there's a difference between brown eggs and white eggs. And to do that, I'm going to go under Analyze and Compare Means. This whole test is pretty much under Compare Means, except for some of the confidence intervals. So Compare Means, and I'm going to do the Independent Samples t-test, okay? And the Independent Samples t-test is going to, I got to clear this out because it doesn't look quite like yours. SPSS leaves in the defaults. So yours is going to look like this when you pull it up. So the test variable is price, but then what I want to do is the grouping variable. And so I'm going to enter color and then hit go. Now I have to define the groups. SPSS isn't going to directly read the brown versus white. I think you could actually kind of redefine things a little. So my first group is going to be B, and my second group is going to be W. It wouldn't matter which one I did first or second, but you have to actually do that step for SPSS won't run the test. So this is all set up. I want to check my options, make sure I'm running a 95% test, unless otherwise. Continue. And then it's all set up, and then I'm going to go ahead and run the test. And my output appears in my output window, which is somewhere over here. Over here. Okay. So this is the test, and it gives me as output the group statistics, which is nice to have. So the brown eggs, the mean price was $4 with a standard deviation of $1.32. The white eggs, the mean price was $2.64 with a standard deviation of $1.18. I really have no idea why brown eggs cost more, but that's just interesting. But are they significantly different? Well, down here we have the test results. This Levine's test for equal variances, the way that Blumen does it is to just assume that the variances are not, assume that equal variances are not assumed, which is the safe way to play it. So we're just going to always use the results for the equal variances not assumed to play along with Blumen. And so you can ignore the first line here. The second line is your test statistic. So this right here, 3.36, this is our test statistic for the difference of the means. If we went and did the formula for that, I don't think I actually, I don't think I hand calculated it. Right here, this is the formula that that test statistic would use, and it would be the brown mean minus the white mean, and then the difference of means would be 0. So the numerator here rather would be like 1.36. And then it would be divided by the square root of this thing here that I'm kind of too lazy to calculate. But all the information to calculate this by hand is in the group statistics table, because you just square the standard deviations divided by the sample size plus square the sample size. And if you actually sat and did that by hand, which admittingly I was even too lazy to do, you end up getting 3.336. Okay. So that's the test statistic. I mean, the test statistic is the game player in these things, right? So the test statistic is 3.36. The p-value associated with it, in this case, it's read right off of SPSS. It's the 0.002. That is less than 0.05. So based on that, I didn't mean to do that. Based on that, we clearly have a p-value less than 0.05. And we can conclude that the null hypothesis that there's no difference in price is rejected, right? Brown eggs are costing more than white eggs. And so there is a significant difference between the mean of the populations in terms of the different colored eggs and egg tests. I do make a note that if we were running this at a 99% level, we would end up with a p-value that was not significant because 0.01 is less than 0.02, and that would be a fail to reject the null. Just make a note of that because we're looking at different tests and different levels. All right. Similarly, I also ran a test of organic versus regular eggs. Basically, it's the same test except the groups are organic eggs versus regular eggs. And I just wanted to see if organic eggs were more expensive, which of course they are. And let's go ahead and run this in SPSS to show you where I got these results from. And so once again, I'm going under Analyze, Compare Means. I am doing the independent samples t-test. I have to define my groups again. Be careful about leaving presets in, you know what I mean? Like, don't just hit go because there's something in grouping. I wish, it would be my dream that software products would not do this because you have to remember to clear things out, and it's very easy to be sloppy and to just hit go. And you don't want to do that. So I just had to I had to clear out the color and enter the grouping variable of organic by flipping around with this thing. And now I want to define my groups, which are yes and no. For organic, and then I want to hit continue. I want to check my level and make sure I'm at 95. You know, SPSS was not like front-end designed. It is kind of annoying to remember to click these little things because you might have just run a test at the 90% level. Now you're running a 95% level. So you got to be careful and you got to, like, you know, hit the right little buttons and stuff, okay? And so it's all set up, so I want to run my test, and voila, this is what I get. I get my group statistics. The organic eggs are $5.09 a dozen. The inorganic eggs are $2.85 a dozen. And yeah, this is the data. So this is just descriptive stats on the top, but then on the bottom we have the independent samples test. Again, we're going to do the equal variance is not assumed, and so this right here is our results. Be careful, this says significance, but this is for the Levine's test, so this value here is not relevant to you. This is the values that are the most relevant to you, is the t statistic and the associated significance for this. And so the t statistic is 6.16. I mean, that's pretty much off the chart for any distribution. It's associated with a p-value of basically 0. Our conclusion is to reject the null. Because there is, in fact, a significant difference between organic and inorganic egg prices. I don't think there's any way that you could run this test and get a non-significant result. I think that the difference here is so strikingly different that it's not like, you know, the brown versus white was rather marginal. That one you could collect more data and make an argument that there's very little difference there. But this one, the organic versus inorganic, there's a ginormous difference between the different groups and the different egg prices. Yeah, and so this is the conclusion is, of course, to reject the null hypothesis and conclude that there is a significant difference between organic and regular egg prices. And that is the two-sample independent means test.